So yeah, I'm going to talk about granular data access control with GraphQL. And before we get into it, my name is Andrew Carlson. I'm the principal field architect at Apollo. And before that, I spent over a decade working with enterprises in the Fortune 100, actually designing and then implementing the architectures that brought them from, migrating old systems of record to new systems of record, as well as decoupling the monolith, breaking it down into individual microservices and stuff like that. And along the way, I really came to care a lot about intent, and specifically intentional design. I believe that everything that we ship has an architecture. Everything that we build is designed in one way or another. It's just up to us to decide if we want to be involved in those decisions, because someone is making them. We should be involved. So we're going to talk about data security in our application. But before we do that, we can't really talk about that at all without talking first about boundaries. The boundaries in our personal lives help keep us connected to our core values. Our most valuable resource is our time. We don't want to waste that. And the boundaries that we set in our personal lives help keep us connected to that and make sure that we don't lose track of what we care about. And the boundaries in our architectures are actually very similar. They help us make similar reasoned and principled decisions about the thing that's most important to our organizations, most valuable, and that's data. And data is incredibly valuable. It is the lifeblood of our organizations. It is the thing that we've been talking for 2 days about securing. And that is evidenced, if only by one number, is that in 3 years, by 2027, the data security market is set to be worth over $12.3 billion. And the reason for that, or at least one of the reasons for that, is because of complexity. That cost is directly related to how complex our systems are. And that complexity can come from really any layer of the stack, whether it's from the presentation layer, where we have our clients. Maybe some of you have been asked to develop a new Apple Vision Pro app in this year. Or maybe there's a merger and acquisition that has led to new aggregation layers or new services that are coming in that you now need to figure out how it fits into your stack today. Or maybe the persistence layer, right? You go back to the office tomorrow or on Friday, and your CEO or CTO stops by your desk and says, hey, what's our vector database strategy? And you're like, well, we're going to use PG Vector, but how are we going to wire it up to the presentation layer, right? And even though we can look at a screen like this and say, oh, wow, this is so nice and neatly labeled, and we have these nice, clean columns here, the reality is it's nowhere near that neat. As soon as we start wiring up data all the way from our persistence layer to the presentation layer, we lose all of those boundaries, right? We have lines going all over the place. And this is a simplified version. I'm sure some of you are working on systems with hundreds or thousands of services, right? And that makes it all the more complex. And so a few years ago, the industry came together and started asking a question. What if we could take what we know and love from the infrastructure as code world and start applying those things to security? We've been looking at this imperatively. We've been doing authorization either at the database level or directly within the services individually. But what if we could take that and start applying that a little bit more declaratively? And the last 2 days should be an indication of how far we have come in just a few short years. There's been an absolute rise in the policy as code toolchain. I threw 5 up here on the screen, but there are even more players in the space, some of whom are here today. But Casbin is a great example. Open Policy Agent, or OPA, it's a recently graduated CNCF project. Sentinel, Cedar, Zanzibar. Some of these are put out by Google, some of these are put out by AWS, and some are open source. The open source ecosystem around this is incredible. And what makes this pattern so important, and right here up on the screen, you should see an example of what a declarative policy looks like using Rego. That's from OPA. But what makes this pattern so powerful is that the alternative it's kind of bleak. It is hoping that you have the right credential to the right database on the right instance, and that you don't fat finger something along the way, right? Or that you don't accidentally nest an if statement incorrectly, imperatively inside your application. That sounds a lot like cowboy coding to me. It's not very intentional, and we can definitely do better. So declarative policies, declarative security is interesting. You're going to go home, you're going to start implementing it in your applications tomorrow, obviously. But where should we actually apply all of these policies? Should we do it in the persistence layer, where our data is at rest? Or maybe the services tier, where we control the bulk of our business logic? Maybe the aggregation layer, where that sort of like last mile before it makes its way out to the clients. It depends, right? But you didn't come this way. You're not sitting here hoping for a mealy-mouthed answer. The real answer is everywhere. And we heard a lot yesterday about this idea of defense in depth. Most organizations will benefit from this, and some would argue that every organization would. And this idea of defense in depth is that you secure every single layer of your stack from left to right. But that begs a question: how do we decide what to secure where, and what is the value of securing each of these individual layers of our stack? So I'm gonna lean back on my consultant background, and I'm gonna pull out a matrix here, okay? This is my way of understanding the world. And in this way, we can measure two different things: the flexibility on the x-axis, or how easy is it to update the policies, and granularity, or how specific can we be? So are we securing a column? Are we securing a database? Or somewhere in between? And what we'll do is take a look at that architecture that we looked at before and simplify it a little bit, okay? And we're gonna drop all the lines from it. We don't need the lines. We're just looking through here. And we're gonna kick presentation off past the right-hand side of the screen, because you can absolutely never trust the client, so we're not even gonna talk about it here, okay? And what we'll do is evaluate each of these individual layers in the stack, and we'll take this topology and put it on top of that matrix and identify some of the benefits and the values of applying, or benefits and trade-offs rather, of applying security in just one of these places, okay? Because remember, we want to look at completing the matrix, but what would happen if we just secured one of them? So first, we'll start on the far right-hand side, closest to the data. This is where data rests. It might seem like the natural place to start. The downside of this is that while we can apply very, very strong security at this level, if we only secure our requests at the database, we're really just securing these general roles. We're securing tables or databases at a time. It doesn't have the granularity that we need for most of our apps. We're not gonna go and just add a new username and password for every single user of our application. That's absurd. So it's not very flexible, and it's not really all that granular. If we hop to the other side and look at applying policies closest to the user, we'll see that we do gain a little bit of flexibility. We actually have the opportunity to secure across more than one database, more than one table, more than one service at a time. And in this case, we're talking about an API gateway. It could be Kong, it could be Apogee, or maybe you hand-rolled your own, right? It doesn't really matter. The idea here is that this is the data, or this is the area in our stack right before data goes back out to the user. But right here, we're basically allowing or rejecting services at a time. It's not all that granular. If we click into individual services, we gain a lot of granularity. But the downside is it's incredibly imperative. Even if we're using this idea of declarative policies, even if we're using an external evaluation agent, inside our services, it's still code, right? Like we can still get lost inside nested if statements or whatever else. And worse than that, what often happens is if you are using an external policy agent as well as handling authorization directly within your services, you can end up with what I call auth sprawl. And the idea here is that you are duplicating your authorization logic in multiple places. And so imagine having an external policy agent where you're evaluating a JOT token, but then you also have a nested series of if statements within your services. It's a nightmare to debug, trust me. You don't want to do it. So let's take a look at all these on this matrix again. Persistence, if we only did this, it'd be in the lower left, right? It's not very flexible, it's not very granular. Again, this is sort of like a database or like Databricks wrapping the MySQL or even an S3 bucket. If we only secure the API gate boundary, then we're looking at something that's a little bit more flexible. We can secure services at a time, but not really all that granular. Individual services, yeah, you can get down and authorize a specific field. Does this user have access to their social security number? Sure, we can send that back. But then you kind of end up with this duplication of authorization logic. And you might notice there's one hole left on the screen, and there's only one layer I haven't talked about yet. But before I get there, let's talk about GraphQL for a second. Now, you may think, as I used to as well, that GraphQL is just another option for our APIs. It's the perennial like REST versus GraphQL, SOAP versus GraphQL, gRPC, whatever, right? Like I see this on Twitter all the time. I see this all over the internet. It's like, how do I choose which one to use? And unfortunately, that's not a very nuanced discussion today. In 2012 or 2015, when Facebook open sourced GraphQL, that may have been the case, but a lot has changed since then. There have been a lot of evolutions in the space, and it is way more than just an option for our APIs. It can be even stronger when we use it together with other technologies. So after Facebook open sourced GraphQL in 2015, a lot of organizations, maybe some of your organizations as well, started adopting GraphQL and then running into some of those side effects of trying to scale the implementations. And that's really what we're trying to look at, is like, how do we operate GraphQL at scale? So in 2017, schema stitching emerged as an option, and we found some success with that. That's a good pattern. It lasted us for a couple years, but I think GraphQL really hit its stride around 2019 when we started identifying ways of really operating GraphQL at scale. And Stefan called this out, the federated GraphQL model, right? And the idea here is really, really interesting. This idea of being able to operate multiple graphs under a single unified surface. And that has taken us forward to today. So 5 years later, thanks to that open architecture, rather, organizations around the world that are powering all of the apps that are on your phones today, right? Like the way we watch movies, the way we order a car, the way we watch sports, all of that is driven by federated GraphQL architectures using tools, many of which are open source, including like Apollo Router and stuff like that. And the reason that it's so interesting, these federated architectures in general, is that it provides this really unified boundary. And it all comes back to boundaries, especially in our application architectures, because this boundary gives us an opportunity to make decisions about granular details like our schemas, individual fields, individual types, or broad things at a time, our entire domains. And it gives us an opportunity for teams to manage every single one of these individual graphs while still having the governance of a unified monolith, right? Benefits of decoupling, governance of a monolith. So if we think of GraphQL as not just an API, not just another REST alternative, but instead as an option for aggregating within our stack, as a core part of our aggregation layer, we can gain some flexibility and granularity that we haven't really seen before. But that's a lot of talking about like why we can. Let's get into how for a second. There are generally two ways of doing this in GraphQL today. And the first place you might think of is, oh, my GraphQL has resolvers. That's where most of my code is, right? But the reality is that that's where most of your code is. So that's where we shouldn't put our declarative policies, okay? Instead, that would be akin to basically managing our authorization individually within our services themselves. It's very imperative, right? A much more interesting place, in my opinion, to look is within the schemas themselves. Our schemas, they're our most declarative part of our GraphQL stack. So let's take a look at what it would look like to actually apply our policies directly there, right? We can pull the logic out of it and just annotate our schemas with what we want to see. And it's really interesting, in fact, because the GraphQL schema, in my opinion, is a bit of a Goldilocks zone. We have defined what our models will look like, but we haven't defined how we're going to access them. And that's okay. We don't need to define our policies next to how we're accessing the data. Instead, we just need to understand the shape of the data that's coming back out. And it's a Goldilocks zone because it gives us the opportunity to be very broad or very granular based on our use case. So if our use case is that we want to secure an entire type, or for example, an entire query, right? We could secure that pretty easily. We could just annotate that however we wanted. But what if we just wanted to authorize a specific field within a type? Well, if we were doing this in a service, we would have to handle that very imperatively through if statements, partial body returns, however you want to do that. But it ends up being fairly imperative either way. But here, we have the ability to just annotate a single field within an individual type. Okay. I don't trust the demo gods or the Wi-Fi here. So I went ahead and recorded some of this. But I would love to actually, like, if you have any questions or you want to see a deeper demo later, let's find me in the halls. I'd love to walk you through it. There are a few different tools. As you can imagine, like demoing authorization within an application is actually, it takes a couple tools to demo. Who would have guessed, right? So we're going to use Postman to issue our GraphQL requests, and we'll see the responses there. We're going to use Open Policy Agent. I mentioned it earlier, OPA, to actually, we're going to use Rego for writing our policy, and then Open Policy Agent for evaluating that. VS Code, obviously, just to look at the code, JOT tokens, JSON Web Tokens, that's where we're going to put that in our header for our authorization, and then Apollo Router we're going to use for just federating all those graphs that I mentioned. And to do this, we're going to have four important things running. Two subgraphs, so we're going to have two individual graphs running, reviews and locations, and then a router that's federating those requests, and then Open Policy Agent for actually evaluating them. And JSON Web Tokens are terrible to demo, so you're going to have to trust me a little bit. I took a screenshot of what I'm demoing, but base64 encoded strings are not fun to read. The important thing to pay attention to here is the payload. In this case, I'm looking for a simple claim, just looking for a username Alice. It can be as complex or as simple as your use case requires. Either way, Rego, the policy language, is more than powerful enough to parse out whatever your payload is. And this is an example of the OPA policy that we're going to take a look at. It looks like a lot of code, 37 lines. 30 of those are comments. Really what we're looking at is we're decoding the authorization header, decoding the JOT token, and then allowing if a claim username is Alice. We're going to look at three use cases. And an unauthorized flow. In this case, well, we'll look at three use cases: unauthorized, authorized, and then a partial authorization flow, which is my favorite. So in an unauthorized example, the client's going to make a request, and it either doesn't have a JOT token or it has an invalid bearer token within it. And that's going to go to, in this case, Apollo Router. And that's going to broker a request. It's going to send that policy and the query to Open Policy Agent and just ask a question: can this person do what they're asking to do? In this case, they're not able to. So we're going to block both of those requests before they make their way to the individual subgraphs, which are over on the right-hand side, the locations and the reviews API. So here I have annotated it with the schema with a custom directive at policy. And then in Postman, I'll just issue the request, and we get an error. Watch it one more time. The directive there, and then issue the request, and it'll fail. So that's an unauthorized flow. Now the authorized is the exact opposite of that. We have a client, and we're going to issue a valid auth token. It will again broker that. The Apollo Router will again broker that with Open Policy Agent, and it will allow both requests to go through to the individual APIs. So here we are looking at two examples, the review type. So we've annotated two types here. I'm going to set the authorization token, the authorization header, and we'll see all the data come back as expected. So again, we have those two. Username Alice is what we're expecting there. And it's just simple strings. You can really do any sort of evaluation. You're kicking it off to an external processing agent. All right. And then this one is my personal favorite. I find it the most compelling. This is the partially authorized flow. And I think this is really interesting because since we are actually defining this in a declarative way before any requests go out to the individual subgraphs, we can do partial resolution of responses. And what I mean by that is if I send a payload and I issue a query and I only have access to some of the data in that request, I can still satisfy the data that I do have access to and then just nullify the fields that I don't, and maybe throw some errors that will help with the individual handling. Okay, so in this example, it's actually similar to the other. I haven't changed any of the code. We have the exact same annotations on locations, but I'm going to turn off my authorization header. I'm going to issue a similar query to before, and here, you'll see that I do get some data back, and I get nulls for any data that I don't have access to, as well as a large error body as well. So down at the bottom, location is null. We'll watch that one more time. We've got our annotations at policy, and then we'll issue that request. And then you'll see some nulls here. So I don't have access to rating or location because I've turned off that authorization header. So this is really interesting. It's a way to actually get that information that we do have access to and reject access in a way that we don't really do with most other API technologies. All right, so if you use GraphQL in this way, as part of your aggregation layer, not just part of another API, but actually as part of an aggregation layer that really rounds out your stack, it has an opportunity. We have a new opportunity ahead of us here where we can actually apply this flexible and granular data access control in a way that we don't if we secure just our services, just our persistence layer, just the API gateway. Now, you should do it all. We need to have defense in depth, but we can really buy a lot of flexibility and granularity doing this as well. All right, that is about my time for today. Oh, I got the stop. I gotta get off stage here. Okay, so you can find me on LinkedIn in the halls. I'd love to talk. You can email me, Andrew at Apollo GraphQL. And also, we have a huge community. Over 1,000 API architects and engineers from companies from around the world are solving this problem, as well as so many more. And so I'd love to talk to you there as well. Email us at champions@ApolloGraphQL. Appreciate it. Thank you.